Hello friends, I am Dr. Prof.Chishty and I am teaching physics to BSc third year students. My today's topic is origin of the spectral lines in the Bohrs theory. I am considering the hydrogen atom for the study of the spectral lines. So when an electron jumps from the higher orbit to the lower orbit, then it radiates the energy as set by the Bohr's third postulate, that when an electron is in the upper orbit having the energy En, it jumps into the lower orbit having the energy Ep, then it will radiate the energy equal to h nu. H nu energy will be radiated, and when there is jump of the electron, this energy is in the form of the electromagnetic waves, and it has the frequency, it has the wavelength. Therefore we say that it is a spectral line. The jump of the electron will produce a spectral line. Electron may jump from the higher orbit to the first orbit or higher orbits to the second orbit, and there is origin of the spectral lines. So we will derive the formula for the spectral line, the formula for the wavelength of the spectral line from the formula of the energy. Energy in the nth orbit is given by minus me raised to 4 upon 8 epsilon 0 square n square h square. Now energy in the p orbit will be equal to minus me raised to 4 upon 8 epsilon 0 square p square h square. Here n and here is p. Now I will use here En minus Ep is equal to h nu, which is Bohr's third postulate. Therefore I will write here minus me raised to 4 upon 8 epsilon 0 square n square h square minus of minus me raised to 4 upon 8 epsilon 0 square p square h square equal to h. For nu I can write here c by lambda. Nu is equal to c by lambda. So I will take here me raised to 4 upon 8 epsilon 0 square h square common. So inside the bracket there will be 1 by p square, minus minus become plus, 1 by p square first, then minus 1 by n square equal to hc by lambda. And I will take this h and c to this side, and I will write the formula as 1 by lambda equal to me raised to 4 upon 8 epsilon 0 square h cube into c, 1 by p square minus 1 by n square, 1 by p square minus 1 by n square. All these things are constant. M, E, epsilon 0, h, c are constant. Therefore 1 by lambda is equal to r into 1 by p square minus 1 by n square. Or you can generalize, you can say that 1 by lambda is equal to 1 by n2 square, n1 square minus 1 by n2 square. You can write like this. With the help of this formula, we can calculate the wavelength of the spectral line in the Bohr's theory, in the Bohr's orbit. So when an electron jumps from the higher orbit to the lower orbit, it will radiate the energy in the form of the electromagnetic waves, and whose wavelength can be calculated using this formula. Now see how many types of series will emerge out from the in the hydrogen atom when the electron jumps from the higher to the lower orbit. So I will draw here the orbits and we will calculate the energy in each orbit. Then I will write here the jump of the electron. So here is the ground state, n equal to 1, having the energy minus 13.6 electron volt. Then second orbit, n equal to 2, having the energy minus 3.4 electron volt. Now here is the n equal to 3, third orbit, energy minus 1.51 electron volt. Then here is the fourth orbit, n equal to 4, energy minus 8.5 electron volt. Then fifth orbit, energy minus 0.54 electron volt. Then sixth orbit, and energy is minus 13.6 electron volts, minus 0.37 electron volt. As we go away from the nucleus, then the orbits will come closer to each other. You can see the gaps. Gap is decreasing when we go to the higher orbit. It means that the energy of the electron increases. So these horizontal lines denote the orbits of an atom, orbits of the atom. Now when an electron jumps from the second to the first orbit, it will radiate the energy. First spectral line, third to the first, fourth to the first, means higher orbit to the first orbit. This series is known as Lyman series. Lyman series. Here P is equal to 1 and N will be equal to 2, 3, 4 and so on. Lyman series. Now when the electron jumps from the higher orbit to the second orbit, then there is the origin of the spectral lines, and this series is called as the Bulmer series. Bulmer series. For Bulmer series, P equal to 2 and N equal to 3, 4, 5 and so on. Formula is 1 by lambda equal to R into 1 by P square minus 1 by N square. R is called as the Rydberg's constant. Its value is 1.097 into 10 to power minus 7 per meter. So here, when the electron jumps from the higher to the third orbit, then also there is origin of the spectral lines. It is called as a Paschen series. Paschen series. P equal to 3, N equal to 4, 5, 6 and so on. When an electron jumps from the higher to the fourth orbit, it is called as a bracket series. Bracket series. And here P equal to 4, N equal to 5, 6 and so on. When electron jumps from the higher to the fifth orbit, it is Pfund series. Pfund series. And here P equal to 5 and N equal to 6, 7 and so on. Only one series, that is a Bulmer series, it is in the visible region, means we can see it is in the visible region. Lyman series is in the ultraviolet region. This series is in the ultraviolet region. Paschen series is in the infrared region. Bracket series is also in the infrared. Pfund series and bracket series, we can say that they are far from the infrared series, far from infrared. So these vertical lines here denotes the jump of the electron from higher orbits. Horizontal lines here denote the denote the orbit of the atom. The figures to the right hand side indicates the energy, and figures to the left hand side indicate the quantum number of the orbit. Okay, so this is known as the energy level diagram for the hydrogen atom. Thank you.